All right, today I'll be covering some examples of dimensional analysis to better explain what it is and how it works. We will start off with a simple example of how to convert kilograms into milligrams and then kilograms into pounds. So we start off with the example having 0.907 kilograms, and we want to convert this into milligrams. One thing we can do is we can write out a linear map of what are the steps we will be taking. So we can solve a large problem and break it down into smaller steps that makes it easier to solve. So kilograms we can convert it into grams, and in grams we can convert into milligrams. All right. So the best way to solve this problem is by doing a box chart method. So we have 0.907 kilograms, and then we just leave the bottom here. We just leave it alone since that'll come in later. So we have 0.907 kilograms. So we want to convert into milligrams. So we need to cancel out this kilograms right here. So one way we can do that is we let 1 kilogram, or we essentially just divide by 1, but we cancel out the kilogram like this. So 1 kilogram equals how many grams? Since we're trying to go from kilograms to grams to be able to reach milligrams ultimately. So there are 1,000 grams in 1 kilogram, as the word kilo means 1,000, like that. So now we want to go from grams to milligrams. So we will write milligrams at the top and grams at the bottom. So when these two cancel out, we end up with the answer that's in milligrams. All right, so what we can do is how many so we don't want to change this 1,000 right here and this 0.907 by anything, so we can just essentially divide by 1. So how many milligrams are in 1 gram? Whoa, milli also means 1,000, but it basically means 1,000, but we need 1,000 of these parts to equal one of these. So we need 1,000 milligrams to give us 1 gram. Now, if we put that in the calculator, we will get 0.907 times 1,000 times 1,000. And that'll give us 907,000. We can write this, milligrams, sorry, milligrams as our answer. We can write this in two different ways. We can write this in scientific notation, which is 90.70 times 10. And then since we put a decimal right here, we would just have to count from right here all the way to right here and see how many decimal points we actually jumped. So let's see, that's 1, that's 2, that's 3, that's 4. So since we jumped 4 decimal places to the left, our our exponent will be positive. But if we were to jump 4 decimals to the right, we will have a negative exponent here, like that. So 90.70 times 10 to the fourth milligrams is our answer. Or if you are forced to write it in engineering notation, which has the exponent being counted being multiples of 3, so like 3, 6, 9, 12, and so on, we will have to write 907.0 times 10 to the third milligrams, as we only jumped 1, 2, 3 decimal places to get the 907 times 10 to the third milligrams. So those are two different ways you can go about writing this problem. Now you can box your answer. And let me write engineering. And this is scientific. And we can put the answer in green. and we can separate it and go on to the next example. Oh wait, sorry, not the next example. We have to convert this kilograms amount into pounds. How do we do that? So you see how we just converted into milligrams, and then grams, and we wrote a chart. For here, we can just do a simple one-step problem. So we go from kilograms to pounds. So we know that 1 kilogram is about 2.205 pounds. Kilograms at the top, kilograms at the bottom, so they cancel out. So our answer will be in pounds. Now if you multiply 0.907 times 2.205, it'll give you 1.99 pounds. Or we could say this is about 2.00 pounds for our answer. Now, our next problem asks us to convert Celsius into Fahrenheit and then convert Celsius into Kelvin. So Celsius to Fahrenheit and then Celsius to Kelvin. Celsius to Fahrenheit is a bit more complex than Celsius to Kelvin. The formula to convert something from Celsius to Fahrenheit is you get Celsius, your reading in Celsius, you multiply by 1.8, and then you add 32 to it, and it'll give you your answer in Fahrenheit. So for this example, we have 20.70 degrees Celsius, and we want to convert this into Fahrenheit. So the way we do this is we just take the 20.70, we multiply by 1.8, and we add 32. And our answer will be 20.70 times 1.8 plus 32 gives us about 70 degrees Fahrenheit. Let me just double check that's correct. Yep, that is correct. Now we need to figure out how to convert Celsius to Kelvin. This is a bit easier, as all we have to do is we just have to add 273.14. That'll give us our answer in Kelvin. So we get 20.70 plus 273.14 equals Kelvin, which is equal to, let me see, it gives us 293.84 Kelvin. For Kelvin, you do not mention degrees, you just say Kelvin. So for here, we say 70 degrees Fahrenheit. We don't do the same thing for Kelvin. We just say 273 Kelvin. We box the answer. We box the answer. And you can just highlight it. And then now on to the next problem. Now the next problem discusses how to convert kilometers to miles per hour, kilometers per hour to miles per hour, and then kilometers per hour to meters per second. So we have 229.8 kilometers, and we want to find kilometers per hour to miles per hour, and we also want to figure out how to do kilometers per hour to meters per second. So a few key conversion rates we might need will be 1 mile equals 1.602 kilometers, and 1 hour equals 3,600 seconds. So similar to the first problem, we will do a box method. So we will have 229.8 0.8 kilometers at the top, and we will divide by 1 hour. Now we want kilometers at the top to cancel with kilometers at the bottom. So we have kilometers at the bottom, and we want to convert into miles. So we have miles at the top. So we can say 1 mile equals 1.602 kilometers. And we can convert this into miles per hour. We can now write m over h because that is assumed to be meters per hour. But if we were to write mph, that is assumed to be miles per hour. So we have 229.8 times 1.602. This gives us, oh wait, no, sorry, not times, it's divided. So that is about 143.44 miles per hour. Now to convert to meters per second, we have 229.8 kilometers per 1 hour. We want to convert to meters, so we'll put meters at the top and we'll put kilometers at the bottom. So we know that 1 kilometer equals 1,000 meters, and we know that 1 hour equals 3,600 seconds. Our answer would be in meters per second, which comes out to be let me see, about 63.83 meters per second. That's our answer for, these are two answers for this question. Now on to the next one. This is a bit more of a real life scenario. Well, not really, because when will you ever really need to measure the width of a red blood cell in your normal life? But here we have a red blood cell. A red blood cell width is about 1.21 times 10 to the negative 8 centimeters across. And we want to convert this into inches. So we have centimeters to inches. Now this problem is a bit more straightforward, as this is also just a one-step problem. So we have 121 times 10 to the negative 8 centimeters. And we want centimeters to cancel, so we will have centimeters at the bottom. And we have a conversion rate of 1 inch equals 2.54 centimeters. So 2.54 centimeters and 1 inch at the top. Our answer will be in inches. So we will have 1.21 divided by 2.54. So give us our answer, 5.00 times 10 to the negative 1, 2, 3, 4, 5, 6, 7, 8, 9. So negative 9 inches. Now this makes sense because the larger the exponent and it's negative, the smaller the number is. And as you can see, 1 inch is equal to 2.54 centimeters. So if you want to go from something larger to something smaller, there will always be, there will be logically less inches to cover the same amount that the centimeters will cover. So that's one way you can look at a problem. So it's about 5.00 times 10 to the negative 9 inches. Now on to the next problem. This problem is a bit more complex because we will have to be converting area, one unit of measurement of area, into another unit of area. So for this, we have 195.7 inches squared, and we want to convert this into meters squared. So we need to figure out a few conversion rates first. So 1 inch, as we saw in the previous problem, is equal to 2.54 centimeters. Now we also know that 1 meter is equal to 100 centimeters. So these are the only two conversion rates we really need for this problem. So we have, we can write a linear problem, a linear example of this to better help us solve this problem. So we have inches, and we can convert this to centimeters, and we can lastly convert centimeters into meters. So we have 195.7 inches squared. So we have inches at the top and we have inches at the bottom. So 1 inch. But here's where problems start to differ. This problem starts to differ. So since our inches here is squared, we need to square this inch right here. So what we do is just square this, and we have 2.54 centimeters. And since the bottom was squared, we have to square the top as well. So that would give us 2.54 centimeters, and this square distributes to the centimeter, and this square will also distribute to the 2.54. So we will end up with something like 2.54 squared centimeters squared. And that'll make sense as this right here is squared and this right here is squared, and inches squared will cancel out. So we will now have to convert from 2.54 centimeters squared to meters squared. So what do we know? 100 centimeters equals 1 meter. But we want our meters to be squared. So we will square meters at the top, and we will have to do the same thing for centimeters at the bottom. And then this will give us our answer in meters squared. As we saw from the previous example, we can expect the area in meters squared to be significantly smaller than the inches squared, as inches squared is a smaller unit than meters squared. So here we just have to put in the calculator. So we have 195.7 times 2.54 squared. And now we divide it by 100 squared. So to give us 0.1262 meters squared. Or we can write this in scientific notation, 1.26 times 10 to the, let's see, 1, 2, 3. It's the, wait, sorry, that's wrong. Yeah. So since the decimal is here, we will just have to count one space backwards. And since we counted backwards, this will be negative, and it's not 3. It'll be just a negative 1. So it'll be 1.26 times 10 to the negative 1 meters squared. And that should be our final answer. Now, for another example, we will have two different examples, but they will cover the same thing, just looking at it from two different perspectives. For one, we will be given mass, and we will be asked to convert it into volume, and then for the second example, we will have been given volume, and we will have to convert into mass. So what am I talking about? So here we have 3.28 grams of hydrogen, and we want to convert the amount of grams into liters of hydrogen. So how do we do this? So we know that the density of hydrogen is equal to 0.089 grams per 1 liter. So we can use something called stoichiometry, which will convert grams of something to liters of something to given a conversion rate. So how does this work? So we would do a box method, so 3.28 grams, and then we know that there's 0.089 grams for every 1 liter of the gas solution. Well, not solution, but gaseous hydrogen. So grams and grams will cancel out, and we will know how many liters will it take of the hydrogen solution to be able to extract 3.28 grams of hydrogen from. So grams of grams cancel out, and then liters will be all that's left. So we will be left with liters. So 3.28 divided by 0.089 will give us 36.85 liters of hydrogen. Liters of hydrogen. And all this is saying is that to be able to extract 3.28 grams of hydrogen, we will need to fill a container up. We will need to fill a container up of 36.85 liters of hydrogen to be able to extract this amount of hydrogen in solid, or at least the mass. That's what, actually no, 36.85 liters of hydrogen. The mass of that is 3.28 in simpler terms, basically. We can highlight the answer here. We can move on to the next question, which is very similar. So for the last question, we have 6.00 centimeters cubed of mercury. This is the elemental symbol for mercury. And the density for mercury is 13.59 grams per centimeter cubed. You might be asking yourself, how do we have a unit of length as volume? So as you can see, you can measure the length of something using centimeters, right? So you can say centimeters, you can say how long something is in centimeters, but you can also say the area of something if you have centimeters in one direction but centimeters in another direction. This right here will give you centimeters squared, and this is what you call area. But to find volume, you can do it in 3 dimensions, and you can say centimeters, centimeters, and centimeters, and it will give us centimeters cubed. This is also known as milliliters, or if you're into medicine, it's called cc's. So when you hear somebody talk about, oh, give this person 45 cc's of a certain medicine, it just means 45 milliliters of a medicine. So saying centimeters cubed is the same thing as saying milliliters, which we can change over here, or we can just call this milliliters. So this is another stoichiometry problem. So we have 6.00 centimeters cubed of mercury, and we want to find out what the mass is of that mercury. So we have 6 centimeters at the top, so we have centimeters cubed at the top, so we will have 1 centimeter cubed at the bottom. So centimeters cubed and centimeters cubed cancel, and then we can find the mass. So for every 1 centimeter cube of mercury, we will have 13.59 grams of mercury. So using this conversion rate, we find that we have 81.54 grams of mercury. All right, that is all. Thank you for watching.